Good morning, friends. Today we are going to discuss Karnataka Kset previous year question paper from 2013 to 2020, number theory and modern algebra. This is a 2020 question paper. First question on number theory. Number of way of selecting 30 elements from a set of 101 elements, where order does not count and repetition here does not count and repetition allowed is that is written as 101 plus 30, 131 minus 1 that is written as 130, and number of way of selecting, that is 30. Therefore option C is correct. Next question. If P is a prime number and G is a non-zero element of the field of P with P elements, then the order of G in the multiplicative group of P minus 0 in option A given is always P. First of all, read carefully question. If P is a prime number and G is a non-zero element, P is a prime number and G is a non-zero element of the field of P with P element, then the order of G in the multiplicative group P minus 0 is here in option A given always P is always less than P minus 1 is always greater than 1. This is always, this is not possible, can be less than P minus 1, can be less than P minus 1. Option D is correct. Next question. The number of generator of the cycle group of 30. Here order of G given 30, that is written as 2 into 3 into 5. 2 into 3 into 5. And here number of generator of cycle group, that is equal to phi of P. What is the phi of P? Euler phi function. Phi of 30 equal to one formula. Put this value 2 into 3 into 5, 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5, and 2 into 3 into 5 into 1 by 2, 2 by 3, 4 by 5. Here cancel, 2 into 4, that is 8. Here answer option B is correct. Next question. If R is a ring of cardinality 25, that is P square, P equal to, here P equal to 5, and with a multiplicative unit, then R may not contain a field. R may not contain a field. Answer A is correct. Next option. If R is a UFD, then R is a PID, R is a ED and UFD. Here given one formula. Field implies ED, ED implies PID, PID implies UFD, UFD implies integral domain. Here given R is a UFD. Here R is a given UFD, that is UFD. First option asks R is the principal domain, converse not true, so option A is wrong. R is the Euclidean domain, converse not true, so P is wrong. Any subring of R is a UFD. Any subring, this is a PID is a subring of UFD. This is also not correct. 3 option wrong, so 1 is a correct option. R may have a non-zero prime ideal, that is not a maximal. Next question. The number of monic irreducible polynomial of degree 2 over the field F5 of 7 elements. Here given 21, 28, 42, 49. One formula. Number of monic irreducible polynomial of degree 2, that is P, over the field F7. Here given F7, that is n equal to 7 of elements. One formula. here number of irreducible polynomial equal to n minus 1 upon 2 and number of reducible polynomial equal to n plus 1 upon 2. Here given number of irreducible, that is n into n minus 1 upon 2. Here n is equal to 7 and 7 into 6 upon 2 is equal to 21. Answer is a 21. Next question. The polynomial f of x is equal to x raised to 4 plus x cube plus x square plus x plus 6 is here 4 option given and one formula. For any p, the pth cyclotomic polynomial, that is 5p of x raised to p minus 1 upon x minus 1, that is x raised to p minus 1. Here p equal to 5. In this example, x raised to 4 plus x cube plus x square plus x plus 6, that is a irreducible over q. In option A given irreducible over the field of rational number. Q is the field of rational number. So option A is the correct. Next question. In the symmetric group S4 on 4 symbols, the number of element of order exactly 4. One formula to find the number of element of order. This is a table for in S4. Order of S4 is equal to 4 factorial. 4 factorial, that is a 24. This is a partition of 4. 1 plus 1 plus 1. Now find order 1. Here LCM is a 1. That is a 4 factor. This is a formula to find order, number of element of order. Here now check for here given order 4. Now check for here LCM is a 4. Only this is a check, and here order number of element of order 4 is a 6. Therefore option D is correct. Next question. In the polynomial ring R of x over real number, which one of the following is a true? Here ask which of the following is a true. Every ideal of R of x is generated by an element of degree 1. Every ideal in R of x is generated by an element of degree less than or equal to 2. Every prime ideal in R of x is generated by an element of degree less than or equal to 2. Option C is correct. Next question. Which one of the following quotient ring is a field? Quotient ring is a field. Option C is correct. Q of x upon x square plus x plus 1. Next question. In a group of order 15, here given a group of order 15 and the number of subgroup of order 3. Find number of subgroup of order 3. Here 15 is written as a 5 into 3 product of prime number, and here 3 does not divide 5 minus 1. 3 does not divide 4. Therefore this is a cyclic. Here is a one note. If order of G is equal to PQ and P is less than Q and P does not divide Q minus 1, then imply G is a cyclic. Then G has a unique only one element subgroup of order 1 PQ PQ. This is a important formula, and here is a P is a 3 and Q is a 5. Therefore only unique, that is answer C is correct. Next question. The number of positive integer less than 51 and divisible by 2 or 3. Here first of all check 51. 20, here 1 to 20 only 10 divisible, and 21 to 40 10 divisible, and 41 to 51 here only 5 divisible. Here 5, And now for a check for a 3, 1 to 30 only 10 divisible, and 31 to 51 only 6 divisible. This is a add, this is a P of A 25, and this is a P of B 16. Now check for a 2 and 3, 2 into 3 6. Now check for a 1 to 51. How many number divisible by 6? Here only 8 divisible by 6. So this is a minus 8 equal to 33. Answer is a 33. Option D is the correct. If G is an arbitrary group of even order 2n, then G has a proper normal subgroup which is non-trivial. G admits a quotient group of order n. G has a subgroup of order 2. This is the correct option. Here put equal to, you can check n equal to 1. Put n equal to 1 here, and 2, 4, 6. You can check every group. G has a subgroup of order 2. Next question. If Z is the center of group G of order 121, that is here this is a P square equal to 121, P equal to 11, and G here is a one result P, then implies center of G equal to P. This is a cyclic, and P square, center of G equal to P square, because this is a abelian. P square is a abelian. So from second result, option C is the correct. Z must be equal to G. Next question. If R is a ED, then which one of the following true? If R is a ED, every ideal of R is a principal. This is correct. Next question. If F is the degree 4 extension field of the field of rational number Q, then which one of the following is the true? F need not be a Galois extension of Q. Answer B is correct. Next question. For n is greater than or equal to 2, let Z upon nz star, Z upon nz star. This is isomorphic to U1 of units of Z upon nz. Which one of the following is a cyclic? Here 1 is the result. U of n is a cyclic if and only if n equal to 1, 2, 4, 2p raised to k. Here p is the odd prime. Now check for option B, D, A. Here only option C is the correct, because 2 into 5. Here 5 is the odd prime. So option C is the correct. Here in option A, 2 raised to n is not a cyclic for n is greater than or equal to 3 here given. So option A is discarded. Here is a check for this is a cyclic or not. Option C is correct. Next question. Which one of the following can't be order of finite field? Can't be a order of finite field. There exists a field P square and P raised to 4. In option check, that is first option is a 5 square. This is a P square, and option C 2 raised to 4, that is a 16, and D is a 3 raised to square. This is a 9. Option B is the correct option. Can't be a order of finite field. Next question. The number of group homomorphism from the group Z5 onto the group Z3. Here is a one result. Number of onto homomorphism from F from M to N. Here M is the domain and N is the codomain. Here number of onto homomorphism exist when M divides N, then only one exists, and m does not divide n, then only 0 exists. Here is a 5. 5 does not divide 3. So here only 0 exists. So option A is correct. Next question, let P be a prime number greater than 1. P is a prime number greater than 1. P is a prime number greater than 1. That is 1. Which one of the following statement is true? Up to isomorphism, there is a unique field of order p square. Option A is correct. In the symmetric group S3, the number of elements that satisfies the equation x square equal to E. Here given S3 and number of elements satisfies the x square equal to E. Now check for S3. S3 is equal to 3 factorial. That is a partition of 3 is equal to 1 plus 1 plus 1, 2 plus 1, 3. LCM equal to 1, 2, 3. Here exists order 1, 2, 3. One formula to number of element of order and find n factorial upon 2 raised to 1 into 1 into 1 factorial 1 factorial. That is 3 into 2 upon 2. That is here only cancel 3. 3 and here exists identity. From identity, this is from identity plus 1 add and 3 plus 4. 3 plus 1 is equal to 4. There exists 4. So option A is correct. If f equal to 1, 3, 5, 6 and g equal to 2, 4, 7, 8, then which one of the following statement is true? Here now check for f and g are conjugate. Here written as a f, here written as a g, and we know that f composition g. This is the answer. 1 goes to 3 and 3 goes to 3. So here 3 goes to 3. So here 1 3 and 2 goes to 2 and 2 goes to 4. This is here both are same, f composition d and f composition g and g composition f. So option A is wrong and option B is wrong. Option C is wrong. Only option D is correct. Now check for next question. If f is a field, then f has exactly 2 ideal. This is a direct result. Next question. If p is a prime number, then which one of the following statement is not true? Here given not true. Any group of order p is a cyclic. Order of g is equal to p, then implies g is a cyclic. If order of g is equal to p square, then this is abelian. Here given in option A, any group of order p is a cyclic, correct. Any group of order p square is abelian. This is also correct. Any group of order 2p is abelian. And any p group of has a non-trivial center. This is correct. 2p is a cyclic or non-cyclic. If cyclic, then it is abelian. Otherwise, this is not abelian. So option C is correct. Next question. The class equation for the symmetric group S3 on 3 symbol. Here 6. If subgroup of order of G divides order of G. Here given in option A 1, 2, 3. 3 divides 6, 2 divides 6 and 1 divides 6. Option A is correct. Here partition of 3, S3. That is a 3 factorial. Partition of 3 equal to 3. So option A is correct. Let R be an integral domain. R is an integral domain. Then R can never be a field. R of x may not be an integral domain. R is not a quotient ring of R of x. Here in If R is an integral domain, then R can never there exists a field, there exists an element, integral domain, there exists a quotient ring of R of X. What option D is the correct option? If R is a quotient ring of R of X, option D is the correct. Next question. Let E1 and E2 be two finite extension field of the field of rational number Q. If degree of E1 over Q is a D1 and degree of E2 over Q is a D2, then E1 is a superset of E2 implies D2 divides D1. Option C is correct. Next question. Let G be a finite group of order n. Then which of the following is true? Finite group of order n. G is a isomorphic to subgroup of Sn, the symmetric group on n symbol. This is the direct result. Let G1 and G2 be two group of order 49 and phi from G1 to G2 be a non-trivial homomorphism. Then phi may not, here given in option A, here always 1 always isomorphism. Here also given always on 2. This is not true. Phi may not be a 1. Next question. In the polynomial ring Z of X over the integer, which one of the following statement hold? Here Z of X has infinitely many ideal which are not generated by single element. Answer D is correct. Let xi be a primitive fifth root of any t. Then xi plus xi square plus xi cube is equal to, here is the one result, fifth root of unity, that is sum of fifth root of unity. Sum of fifth root of unity is equal to 1 plus xi square plus xi cube plus xi raised to 4 equal to 0. And now take here given xi plus xi square plus xi cube equal to minus xi raised to 4 minus 1. That is option B is correct. Next question. Let P1 and P2 be two positive odd integer and S be the set of positive integer less than or equal to P1 P2 which are co-prime to P1 P2. Then the cardinality of S. Here put P1 equal to one prime number, P2 equal to another prime number, and check this is the option A is correct, may be equal to P1 minus 1 P2 minus 1. If X is a positive integer satisfying X equal to X congruence to 3 modulo 7 and X congruence minus 3 modulo 11, then find such X. Find such X, there exist infinitely many such X. This is for homework. Next question. The number of primitive 11th root of unity. One formula. Number of primitive fifth root of unity equal to phi of p. Here p is given 11. P is given 11 and phi of p equal to p minus 1. P minus 1 equal to 10. Answer C is correct. Next question. The number of subgroup of cyclic group of order 20. Here find the number of subgroup of cyclic group of order 20. One formula to find number of subgroup or cyclic subgroup equal to tau of n. What is the formula? 20 is equal to, that is written as a 2 raised to square into 5 raised to 1. Here is given 2 plus 1 and here is given 1 plus 1, that is a 3 into 2, that is 6. Option A is correct. Next question. For which prime p in the following both minus 1 and 2 are quadratic residue modulo p? Answer is the 17. Next question. Let P be a prime and F be a field with the P square number of element. Then the number of ideal in F is a, here is given P is a prime and P square. P and P square 2 element. Number of ideal is the 2. Option C is correct. Which one of the following statement is false? Here ask false. If P is order of group G is equal to P, then it is a cyclic. P square it is a abelian. Any group of order 4 is a cyclic. But converse not true here. Cyclic implies abelian. Abelian does not imply cyclic. So option A is not correct. Here ask false. Therefore option A is correct. In option B, this is a P square. This is a prime, and option D also correct. Here is one important formula. The number of conjugacy classes of the element of the symmetric group S4 on 4 letter. Here number of conjugacy classes of the element of the symmetric group S4. What is the formula? Partition of 4. That is a 5. 1 plus 1 plus 1, 2 plus 2 plus 1 plus 1, 3 plus 1, 4, and 2 plus 2, and 2 plus 2. Here total 5. So option C is correct. Next question. Let Sn be symmetric or permutation group on n elements. Then which of the following statement is true? Answer is every element of Sn is a product of odd permutation. This is for homework. In the ring of integer, the false statement in the following is. Here ask a false statement. Every ideal is a principal. This is correct. Every non-zero prime ideal is a maximal. This is also correct. Every maximal ideal is a prime. Every prime ideal is a maximal. This is wrong. So option C is correct. Next question. Let Z of I denote the ring of Gaussian integer and n be a positive integer. If Z or I divides n upon Zi is the integral domain, then n can be. Here is one formula to find Zp or I p equal to 4k plus 3. Then it is a integral domain. Then it is an integral domain. Here given integral domain. It is of the form p equal to 4k plus 3. So here 19, that is written as a 4 into k. Here k equal to 4 plus 3. Other are wrong. So option B is correct. For a prime p, let F be a finite field with p raised to n element. Then the false statement in the following is false statement. This is a false statement, and this is correct. This is correct. This is correct. Next question. Let F be a finite field. Then which one of the following statement is true? Which of the following statement is true? F is not a subfield of field of complex number. This is a true statement. Other are false. Next question. Let K be an extension field over a field F. Then K is an infinite dimensional vector space over F if K is not a algebraic extension of F. Answer B is correct. The number of different committee of 5 members that can be formed from set of 8 members, that is 8 here written and 5 here written. And C, number of different committee, that is 56. What is the NCR formula? N factorial upon n minus r factorial into r factorial. So option B is correct. Next question. If A and B are two distinct integer, then there is always an integer x such that, here put a is equal to 1, x is equal to 15, and b equal to 5. In option A, check x minus a, 15 minus 1. that is divisible, and 15 minus 5 that is not divisible, so option A is wrong. In option B, x minus a and x minus b divisible by 7 and 49, this is wrong, this is wrong, so option D is correct. Let G be a finite non-trivial cycle group. Here given a finite non-trivial cycle group. Then the number of normal subgroup of G. Here 2. Order of group G is a prime. Then 1 and P. 2 normal subgroup. Next question. The number of 5 silo subgroup of the symmetric group S5 on 5 symbols. This is for your homework. 5 plus 1 equal to 6. So option A is correct. Next question. The common solution for the system for congruous x congruous to modulo 3, x congruous 3 modulo 5, x congruous 2 modulo 7. Here put this value in x and discard option 1, 2, 3. Now put x is equal to 23. This is a satisfies remainder, so option D is correct. In the ring of Gaussian integer z over I, each one of the following statement is not true. Here only inverse in z over I plus or minus 1 plus or minus I 4 units, and 1 plus I is irreducible, 2 plus 3I is irreducible, 17 is irreducible, so option D is the correct option because not true. The roots of the equation x raised to 18 here given, and put x is equal to 5, 10, 17 and 19 and satisfies this value. Here remainder is 0, so option C is correct. If A is an element of group G, the order of A is n. Here given A is an element of group G, the order of A is n, and P is relatively prime. Instead of Pn equal to 1. Now find order of A raised to P. Order of A raised to P equal to n, that is option C is correct. The common solution for the system of congruence is, here put this value x is equal to 23 and satisfy remainder, so option D is correct. If phi is a Euler phi function and phi of n equal to 2 modulo 4, then n which of the following? And now take for option A 49, n is equal to 49, and now find here given a phi of n, and now find phi of n. Phi of 49 equal to 7 square into 1 minus 1 upon 7, that is 42, and put this value in 42, that is put here, and 42 congruous modulo 4, that is 40, remainder is 2, so option A is correct. If f k l are of fields such that L is a finite extension of K, here this is given, and L over F equal to L over K into K over F, that is divided by K over F, we get L over F. Here find L over F, this is option B is correct. Next question. If the polynomial x raised to 4 plus 1 over f is an irreducible polynomial, then f, here is one formula, nth cyclotonic polynomial, that is x raised to, here p is given 5 and other is 0, so irreducible over q, that is over q. Option D is correct. If R denotes the field of real number, then R of x upon x square plus 1 is a field isomorphic to C. Here R cross R, that is R square isomorphic to C, so option B is correct. The remainder when 7 raised to 5000 7 is divided by 23. This is for your homework. Option C is the correct. Next question, the order of two Cyrus subgroup in the symmetric group X6. Here S6 is given, that is written as a 5 into 3 square into 2 raised to 4. And now find order of two Cyrus subgroup. That is the order of two Cyrus subgroup is equal to 2 raised to 4. That is 2 raised to 4 equal to 16. So option A is correct. Let G be a cyclic group of order 10. Let G be a cyclic group of order 10. Then the find a number of element of order 5. Here is one formula to find. Here is given PQ, P is less than Q, and number of element. Here is the number of element of order Q equal to phi of Q, and P equal to Q into phi of P. Here given in option, in question given phi of Q. Here Q is given 5. Here Q is given phi of P equal to P minus 1. That is 4. Option A is correct. Next question. If n is the smallest integer such that phi of n upon n is less than 1 by 4, here phi is the Euler phi function, then n is which of the following? And take a suppose I take a option A 210. Now find a phi of 210 upon n. N is given 210 and find its value, and this is less than 1 upon 4. Then option A is correct. Next question. Let f5 of x denote the polynomial ring over the field f5 with 5 elements. Which one of the following statement is true? Answer is f5 of x has infinitely many quotient ring whose cardinality is bigger than given number. So option B is correct. Next question. Let s is equal to x such that x is an integer divisible by 20. Then s is closed under multiplication. You can check. Next question. Let s is equal to 1, 2, 3, 4, 5, 6. Then the cardinality of the set of permutation of s which fixes exactly 2 elements. Answer is 135. Let p and q be two distinct prime numbers. Then the number of integer a, 1 is less than a is less than pq, which are co-prime to pq. Here put p equal to one number and q equal to another number, and now that is a condition satisfied. 1 is less than a is less than pq, product of two prime number, and which is co-prime to pq. Here option C is satisfied. Let E be a finite extension of the field of rational number q. Assume E over q is greater than 2. Which of the following statement is true? Option B is correct. Only finitely many q vector subspace of E are a subfield of E. Next question. Let Z over I denote the ring of Gaussian integer. Which one of the following statement is true? For any non-zero prime ideal P of Z over I, the intersection Z intersection P is non-zero ideal. Option D is correct. In an integral domain R, which one of the following hold? In integral domain, which of the following hold? For ABC belongs to R minus 0, if AC equal to BC, then A equal to B. Next question. The polynomial f of x is equal to x raised to 4 plus x cube plus x square plus x plus 1 from result pth cyclotomic polynomial, that is irreducible over q, irreducible over the ring of Z. Q over q then implies over Z, that is irreducible over Z. Next question. The ring M2 over R all 2 cross 2 real matrix is an associative ring. Let Z or I denote the ring of Gaussian integer. This is also repeated. In the set of integers, the relation A divides B, that is written here, A divides B. If A divides B and take another number C such that B divides C, then implies A divides C. This is a transitive relation. Or another method, A is equal to put A is equal to 2, B is equal to 4 and C is equal to 8. Here 2 divides 4 and 4 divides 8, then implies 2 divides 8. The center of group G is always normal subgroup of G. This is the direct result. Let G be an abelian group. G is an abelian group, then every subgroup of G is normal. This is the formula. P square is abelian, index 2 is a normal, prime order is a cyclic. Next question. Let Z or I denote the ring of Gaussian integer. Which of the following value of n is the quotient ring Z of I upon n Z of I is a field? This is also repeated. Here is a one result. P is equal to 4k plus 3. Then it is a field. Here given a field. So 11 equal to 4 into 2 plus 3. 11 satisfies, the option D is correct. The integral domain in the following, which is not a PID, that is principal ideal domain, from table Z of x. Here given a Z of x. Z of x is a not a field, not a ED, not a PID, but UFD, but it integral domain. So option B is correct. If F is a subfield of K is a subfield of L or a subfield extension such that K over F is equal to 3 and L over F equal to 6, that is 6 is equal to 3 into 2. Next question. If f of x is any polynomial of degree 19 with real coefficients, then f of x has at least one real root. That is, order degree polynomial has at least one real root. So option, every odd degree polynomial at least one real root. So option A is correct. Next question. If alpha equal to 1, 2, 3, 4, 5, 6 and then find alpha square, that is alpha square 1, 3, 5, that is here, and 2, 4, 6, that is here. Option C is correct. Next question. If G is a group of order mp raised to k with mp, GCD of mp equal to 1 and k is greater than or equal to 1. If h and k are two subgroup of order p raised to k, then which one of the following statement is true? Kh is equal to hk for all h belongs to h, k belongs to k. Option C is correct. Next question. In the ring of integer z, if I equal to 1, 5 and j equal to 2, 1 are two ideals, then the ideal I plus j and I intersection j are respectively given by, here I plus j, then find GCD of I and j, and I intersection j, then LCM of I and j. So option C is correct. Here GCD is 3 and LCM is 5 of 21 and 15. Next question. If G is a group of prime order, then G is a cyclic. If P then is cyclic, P square is a billion. For which value of n primitive root modulo n does not exist? Here is the one result. Primitive root exists only for 2, 4, p raised to k, 2p raised to k. Here p is a odd prime. Now check for option 8. Option D is correct. Which one of the following statement is not a true? There exists a field with 5 element. There exists a field with p square element. And there exists a field with pq element. Here is there exists field with 36. That is 2 into 3. 6. Option C is correct. The number of conjugacy classes in the symmetry group S5 equal to partition of 5. That is partition of 5 equal to 7. That is 5, 4 plus 1 and 3 plus 2, 3 plus 1 plus 1, 2 plus 1 plus 1 plus 1, 1 plus 1 plus 1 and 2 plus 2 plus 1. There is the total 7. Option D is correct. The ring of all 2 cross 2 real matrices with respect to usual matrix addition and multiplication. Next question. Statement 1 is given. Every isomorphic image of cyclic group is a cyclic. This is correct. And every homomorphic image of cyclic group is a cyclic. This is also correct. So option D is correct. The polynomial of x equal to x square plus x plus 4 over z11. Z11 equal to 0 to 10. And this is for your homework. Next question. Which one of the following statement is not true? Any group of order 4 is a cyclic. This is not true. Any group of order prime order is a cyclic. This is a cyclic. This is a cyclic. Option A, B, C are correct and D is wrong. If P is a prime number and G be a group of order P square, if G is not a cyclic, then the number of element of G of order P is a P minus 1. That is 5 P equal to P minus 1. If phi denotes the Euler quotient function, then the any positive integer n, the sum. This is a formula. Here n is a sum of that question. Next question. Which one of the following statement is not true? Here option is wrong. Which of the following statement is not true? Here this is not true. This is a true. This is a true. Here 3 solution, 2 solution, unique solution. This is not true. Which of the following statement is not true? You can check. Next question. Z2 over x upon x cube plus x square plus 1. Here is Z2. Z2 into Z2 raised to 3. That is 8. A field with 8 element. Consider the ring R is equal to Z root 5. Here is given root minus 5. This is only UFD. This is only ID. Here ask not true. This is a correct statement. This is not UFD. Here ask not true. This is also correct. And this is irreducible. But alpha is not a prime. Alpha is a prime. This is not true. So option D is correct. If F is a subfield of K is a subfield of L, be the field extension. If F is a field with 4 elements, which of the following is a possible? Here is the 2 raised to 4, 2 raised to 2, 2 raised to 4, 2 raised to 8. Here 2 divides 4 and 2 divides 8. So option C is correct. Thank you for watching this video. Give me feedback of this video, like, share, comment, subscribe. Thank you for watching.